Welcome, I'm David. This is still the ITOT Insider, and in this video, I'm going to show you what it takes to build an industrial data platform. What capabilities do I need? What should I include in my RFI or my RFP? It's a topic I've been working on quite a while, and I think it's about time to publish a first version. Okay, so before we start, let's take one step back. What is the problem? Why do I need a data platform? Is it because it's fancy and cool to have one? No, there is actually a very simple reason for that. And this graph, I use that quite a lot. I published this graph in an article I wrote just before summer. The article is called "It's the Platform, Stupid," and you can still find it on the blog on itotinsider.com. On the horizontal axis, you see budget, people, time, basically money. On the vertical axis, the y-axis, you see the successful data use cases we delivered to our business, to our internal or external users, to the ones who need to use our data use case. Might be a predictive case, might be about quality, doesn't really matter what it is. And what we hope to achieve when we have a data system in place is that let's say if we double the amount of people in our team, if we go from 1 to 2 or from 2 to 4, or if we double the amount of money, that the minimum I hope to get out of that is the dotted line, which means that twice as much people give me double the outcomes. But what we see happening in reality, what I see happening in reality, is the bigger our systems become, the more source systems we have, the more platforms we have, the more people which are involved, the more people who want to have a say on how data looks like or how data should be used, etc., etc. Is we actually see the red line, and the red line is basically we are stalling. The more people we have, by having more people or by investing more money into our data systems, we see that organizations have a tendency of slowing down in the results they deliver. And what we hope to achieve is the green one. So, which means that we get some kind of an exponential growth. It becomes easier and easier and easier to work with data in the organization. And basically what we want to achieve, and this one is also visual from this article. What we want to achieve is we would like to have some kind of a centralized data platform, and within that data platform, we want to have data readily available for all users. So it's already, I would say, sources are connected, the data is integrated, maybe already from a higher quality. We have context available. So, for example, we know production events. And what it basically happens, what that basically results in, is that where a typical data analyst, somebody who's using data, typically would spend most of their time in getting the data, so finding the data, integrating the data, cleaning this data, and then I would say afterwards, the smallest amount of time is then occupied in doing the actual analysis. We want to turn that around. So we want to make sure that the data which is in the platform is in a very easy way available for you to easily get access to it. And then the person who needs to analyze the data, whether it's a data scientist, whether it's an operator, whoever in your organization, can do that by just, I would say, a couple of clicks. And what you see here in this diagram is that you actually see the preparation time from data use case 1 to 3 to 3 to so from 1 to 2 to 3. The preparation time, so the time it takes you to find the right data and integrate it into whatever tool you're using, is declining. Obviously, it might not go that fast, but the idea is that every time I do a project, I basically make my data platform smarter. So I add more data, I add more sources, I add more context, but also I'm feeding back my results. For example, I'm feeding back cleaned data sets. Or if I'm developing a model or a virtual calculation or an OE calculation or whatever, I'm actually feeding back that information into my data platform for the next user to use it. All right, so that's a bit the idea, the why question. But how? Uh, how do we do this? How do we achieve this? And I want to go back to a LinkedIn post I did in, I would say, in August somewhere. I said like, yeah, community. Yeah, I'm starting to think about developing a capability map, a concept to, I would say, um, make it a bit easier for all of us to understand what is going on in the world, to make it easier to select a data platform. And I got an enormous amount of input, which is super interesting, both, I would say, mainly from technology vendors, but also I had quite some interesting interactions with end customers. And I think the one thing, or the one common thread in all discussions is that there is a lot of confusion today in the market. Answering this question a couple of years ago was very simple, right? You selected an OT data platform from one of the major vendors in the world. Done deal. That's it. If you need to send some data into a cloud system, yeah, you made a small interface, or you use some kind of a application which provided a data integration layer, and you would just pick that data, send it to whatever report was required. But that's it. Today, the market is totally different. We've been talking obviously on the blog and in these videos a lot about IT OT convergence. But what I see happening is that, especially from a data perspective, this is now getting, I would say, getting faster and faster. We see that a typical data problem today is now owned by, or more and more owned by, people from the IT side, from the data side. So you have this, I would say, confusion, gray area, where on the one hand you still have your OT components, on the other hand you see more and more IT ways of working, IT technologies also coming into this domain. You still have the traditional vendors. You have the pure IT data vendors who, I would say, start to expand towards manufacturing. And then in the middle, you have an enormously, I would say, active domain of startups and scale-ups who are also providing very specific manufacturing-focused expertise. And with that, I obviously got some conflicting input as well. Not everybody has the same vision on what should happen. Ones are more OT focused, the others are more IT focused, others have a totally different vision. So I wanted to create some clarity. So I decided to publish now his very first version of this capability map today, which is definitely not perfect. You can find the full capability map on the blog on itotinsider.com. It's definitely not perfect, but for me, I see it as a starting point. So if you are an end user, you can use that information. If you have an RFI, RFP process ongoing, you can use that information in that process. And from a technological point of view, from a vendor point of view, I can use this article, I would say, to streamline my interactions with them. And with that, please provide me with all your comments and feedback. You can find me on LinkedIn or via email, david@itotinsider.com. Okay, so how does a data platform look like? Okay, there is a connectivity part. So somehow you need to talk to either traditional legacy sources, traditional OPC servers, SCADA systems, systems which might be in your plant already or running for many years. You might even want to talk to specific protocols, to PLCs directly, doesn't really matter. You also want to support more, I would say, newer technologies, MQTT, for example. But from I would say today, 2024, it's almost 2025, you also need to make sure that you integrate with cloud systems, with IoT devices, right? There is no, it's not, I would say, your data platform is not bounded to only on-prem devices or traditional wired maybe devices any longer. So you want to make sure that also that cloud layer, that IoT layer is there. Interesting question here is also from a security point of view, right? Traditional plans typically still adhering to some kind of a Purdue model, layered model, where in the IoT world, well, basically everything is running in the cloud. So somehow you have all these data sources. You need to have a connectivity layer. Um, then in the middle, you see the central data platform. It's where the data combines, and the blue circles around it are, I would say, is a visual representation of contextualization, because some of those data sources aren't sensors, might be events, might be MES data, might be quality data, might be maintenance data, etc., etc. Now, on the one hand, you either want to ingest that data or you want to link to that data, and depending on whether or not you want to copy the data into your platform. But more importantly, you want to have those data sources available as context. Context means that, for example, I know when a certain production event happened, I know what batch I was producing from when till when. And that information in the platform gives me the possibility to then get, for example, an energy meter, and I say, like, I just want the energy consumption for that specific batch or that specific product, or when there was an unplanned maintenance, etc., etc. This is the context. So that's number one. Then you obviously need some kind of a storage layer. So you wanna not only have data as this right now in some kind of a broker. No, you also want to store your data for historical, I would say, to do analysis and to go back in time, etc., etc. And here we see already a little bit of a difference between more traditional systems versus cloud systems. So do you want to go for a solution where, I would say, the platform holds the storage as one, as one system, as one entity? But especially when you're using cloud storage, you want to have this, bronze, silver, gold type of structure, delta structure, medallion structure, and I'll come back to that later. And then finally, and obviously, you have data consumers, both users as well as applications. So this is the generic concept of a data platform. Again, this is an article I published also a while ago. And now I would like to add I would say I want to add my different capabilities on top of that. Because if you go to a vendor and you ask, okay, I need something, you should translate this first into capabilities, which matter for you. So the first capability you need in your platform, obviously, is the connectivity layer. I already discussed that. So you want to have connectivity to to other historians, to OPC sources, MQTT, etc., REST APIs. You want to parse JSON files or CSV files. So you want to list, I would say, your specific connectivity requirements first. And then also think about, do I need buffering? Do I need redundancy? Um, uh, for example, if you're working in an industry or a place where you know your connection is unstable, you want to have maybe buffering capabilities on disk locally before you send your data into the platform. Do you want to have a publish model where you're publishing data into the platform, or do you want to go more for a poll model where the platform polls data from you? So that's the first capability. Second capability you need is the contextualization and data management layer. Data management is nothing new, right? We've been talking about data management for many, many years in the industry, but for some reason it was always a bit of an afterthought, in my opinion, right? Whereas in the IT world, data management is something very normal to do. Hey, just imagine having an ERP system without a data management model attached to it. Everybody would be sending their own invoice, their own style, or make their own vendors or whatever. So that means that you need some modeling, management capabilities, maybe even versioning capabilities. Basically, you want to build some kind of an ontology. An ontology means that you actually represent your process, and it's more than just an asset structure. It's also how your process interacts with each other. Um, which means that you need to have that capability. You also need to have you need to have that management capability somehow to manage those. I would say that context, to manage the definitions, to ingest definitions, but also to query those definitions back. I would say out of your system. And I already mentioned it, but asset context is a typical one. But of course also production context, maintenance context, quality context, etc. Maybe even financial context. And there are definitely many more. Things to find, which leads us to something specific, something which is new. Yeah, I even call it a new kid on the block. It is linked to data management. It's linked to data governance, but I wanted to point it out very specifically, and that's data quality. Now, when I talk about data quality, I mean sensor data quality. Is making sure that the data which is measured in your plants, at your sensor level, and so in your connectivity layer, that the data which is measured is actually the right data. So that means that, is my sensor working? Do I have flat lines or spikes or other numbers or drifting data or data which starts to correlate with another measurement, whatever, right? All kinds of sensor data quality issues. And why do I say it's a new kid on the block? It's because, well, there is not really, I would say in the past years, not much work has been done around data quality. Yes, you can have some checks on low limits and high limits and etc. But really going in depth, which means really monitoring your data at scale, is a new capability I see coming up in the market now. And where do you find data quality? I would say typically in regulated industries. If you need to check your data quality, for example, in the water industry, or if you have certain requirements in reporting emissions, etc., etc. So you want to monitor your data quality and maybe also even improve your data quality, which is tightly linked to this raw bronze and cleaned silver store. Maybe you want to store your raw measurements, but potentially also your quality information or even a cleaned data sets. That leads us to the data broker, the data store. That's where we store the sensor data, where we store the event data, where we store potentially maybe alarm data. And it is, I would say, you can't decouple that from the data store itself. The broker and store, they need to work together in perfect harmony. You do not want to have the complexity of managing both things individually. So you have this data store, data broker, where your data resides. If it's cloud native, you might want to think about hot, warm, cold storage, etc., just for you to, I would say, maybe reduce your cloud storage costs a little bit. And obviously, you need a way to get the data out of the platform, both the raw data as well as the contextualized data, interpolated data. You maybe even want to stream data, etc., etc. Okay. We still have one thing, we still missed one thing, and that's the analytics layer. With analytics, in this case, I don't mean the data scientists, the ones who are building models, advanced models, AI models, whatever. No, I really mean edge analytics. So the analytics you want to do at the edge, for example, you have a video feed, and I would say you're constantly analyzing the video feed, but you're only storing certain calculated features into the platform. Or maybe you have a high frequency measurement, and you don't want to store 50 kilohertz data in your platform, but you want to store, I don't know, second averages, something, whatever. But anyway, you want to do some edge analytics, edge processing in many cases before that data is stored into your data platform, or you just want to have advanced integration possibilities to other data sources. But you also, in many cases, need analytics in the platform itself. For example, you might have a calculation which you just, a virtual tag, for example, which you just want to calculate constantly, time and time over and over again. An OE is a typical example, but you might want to calculate a differential pressure on a distillation column or something like that. something which you want to program into your platform. You want to have that virtual calculation that's available in the platform for everybody to use. And that brings us to 6 and 7, which is the visualization part. You definitely need visualization as well. And data sharing. Data sharing means getting your data to other users, to other applications. Might be applications for a specific a specific purpose, like an energy monitoring application, or an application where you, I would say, sharing certain data, certain tank levels with a vendor. Might be for data engineering, data science use cases, etc. So these are the 7 main capabilities. But that's not all, because for every of these capabilities, you need to decide on a deployment model. Do we deploy it on the edge, on-prem, private cloud, public cloud, etc.? And that might differ from capability to capability. You might have a connectivity capability which is deployed on-prem. You might have another one which is running in the cloud somewhere to ingest IoT data. Is your platform, is that running on-prem, in the cloud, or in a hybrid solution, etc., etc.? So you do need to decide on a deployment model for the different capabilities. And then finally, there are some what I call supporting capabilities, but obviously you have cybersecurity, you have user management, and you also have, very importantly, lifecycle management. And lifecycle management is a very broad capability, but that means monitoring if everything works, deploying changes in a scripted way, for example, where you can just push a certain change to some of your local edge nodes, etc. So these are the main capabilities and the supporting capabilities. And finally, some last remarks. First of all, I didn't decide which ones are important for you and if some are more important than others. Something you need to decide yourself when you're starting with such a project. But, and especially now in this time, go for open interchangeable components. Make sure that you can always access your data. Make sure that the solutions you buy are well documented, can interoperate with other systems. And whether or not it's open or closed, so it really doesn't matter in this discussion. Because even an open source kind of solution can still not be open, right? But you want to go for open and interchangeable components. And then make sure to deliver value at every level of your organization. Don't just do this project to enable your data science people, because it's going to cost you money. The ROI of building such a platform that is non-existing. The ROI will only follow when use cases are being implemented. It's also very important to start small, right? Don't go for a big bang. No, choose a couple of use cases, build your platform around these use cases and extend. But make sure that every level of your organization, that means include the operators as well. You don't want to give the operators a Python script. No, you want to give them something where they can just click on a tag and view a trend. But on the other hand, you also want to make sure that your data science person is really enabled to do whatever he or she wants. And finally, compare apples to apples. Comparing apples to apples means that don't just look at the license cost, but look to your I would say your full project scope. What are the ongoing costs? On what factors depend your ongoing costs, especially when you're running in the cloud? Do I have compute costs? Do I have storage costs? If I'm using open source components, how is the support model around that? How many people do you need, internal or external, to run this thing? What are your internal infrastructure costs, etc., etc.? And that's really important to have to take that also into account, because one solution might look cheap in the beginning and end up very, very costly in the end. So yeah, that's it. This is actually the basic introduction in what it takes to build what it takes to build an industrial data platform, your 7 main capabilities, the deployment models, and your supporting capabilities. You'll find a first version of a article on the blog on itotinsider.com with more detail. You can use that detail into an RFI, RFP with your vendor. And I would say to end this video, let's discuss. Um, Enter your comments here on Substack via LinkedIn, doesn't really matter, but I'd love to get your inputs. On the blog, I already listed I would say an initial list of 20-ish, 25, I think, vendors who play a role today in this ecosystem. There are obviously many more. I did not yet, I would say, link capabilities to their systems, because that's actually quite a time-consuming job. But if you have input, let me know. If you want to find some vendors who are active in this domain, go to the blog. And with that, thank you for listening, and until a next time.